Past August, several members of the fire service industry, the State Police Fire Investigation Unit, Marshall Davin, the Hazmat guys, participated in a day of lithium-ion battery mitigation experiments. These experiments were intended to prove or disprove various mitigation tactics that are being used around the country. Firefighter Travis Rebello of the New Bedford Fire Department and an assistant coordinator here at DFS for Hazardous Materials Response organized this event in New Bedford. To discuss these findings, we also have Mike Monaco, 20 years at FDNY, 18 of them with Hazmat Company 1, and just retired, what, a month or two ago?
April 29th.
A few months ago. He's also co-owner of the Hazmat Guys podcast, and he's responded to hundreds of lithium-ion battery incidents. So with that, Mike and Travis will walk us through the testing that was done in New Bedford.
Hi, everyone. Thanks for coming to this. This is going to be just a quick overview of what we did and what we found. I just want to point out I'm not here to bash any company or any individual product. Everything that we found has limitations, right? All the products that we utilized with this may not have worked as well as we'd hoped, but they still do work to some extent, and we still do utilize them. However, we did find some shortcomings with some of them. So to first set it up, I just want to talk about how we set this up. And but Mike is the one that kind of engineered most of these tests and really kind of set the pace for the day on how we did everything. So if you have any questions on the actual setups, Mike's going to be the guy to talk to. Also, I don't think he can stay for the roundtable discussion. So if you have any questions before we finish on anything that the FDNY has done with their battery response, these guys have been right at it for quite some time. How many fatalities have you had so far this year on them?
I believe the city's up to 32 fatalities in the year, and the total is over 100 since we started tracking this in 2000.
So yeah, these guys have been dealing with it for a while, and they've been ahead of the game for a little while now. So when we did this whole experimentation was kind of a public-private partnership where we had the city of New Bedford, we had the Department of Fire Services, we also had the Hazmat guys come in, and as we went along, it kept growing. There were some meter companies that were out there that said, hey, if you're going to be putting these in the Runaway, we want to see what the off-gassing is, see if we can find out what exactly is coming off of these. So Blackline Metering came in. FLIR actually runs GCMS, gas chromatograph, mass spectrometry. They brought that in so we could actually sample with pretty high-end scientific equipment. The guy from Far West came in, helped run it. Red Wave came in, did some air sampling on their FTIR metering. So it was a great collaboration between all these different agencies. What we were really looking for was to find out if batteries in different states of charge are going to cause problems for us. Full state of charge as opposed to 50 and 25% charges. Were there real differences on how those batteries went into Runaway? Again, we wanted to find out what gases were coming out of them. We wanted to find out if our meters were capable of seeing any of those gases. And we wanted to test how our overpacking worked. We decided in the city of New Bedford to go with a product called Cell Block EX, which is a recycled glass material. And that was after a lot of conversations with the FDNY and how they did stuff. So we kind of invested heavily on that, and we wanted to see if we were on the right path with it, if it was going to be working for us. Absolutely, sir.
So as we move forward, one of the things pretty much everybody here I was told is administration and the chiefs of the upper ranks. Some of the things that we try to do during the classes is to refocus our brains and understand that when we're dealing with the batteries and we're looking at everything that we're going to see, that especially as a chiefs, we're dealing with two separate issues. We're dealing with the issue of the battery that started the fire that we're responding to, but separately, we could potentially be dealing with the battery that is affected by fire that our firefighters are responding to. So those are two separate things, right? From a scene safety point of view, from an IC point of view, I don't really care about the battery that started the fire. It doesn't mean anything to me anymore. I understand there's things I now have to do because the battery started the fire. What concerns me and what kind of keeps me awake at night sometimes is the understanding that if the battery goes into thermal runaway while our firefighters are doing their search, while they're in there performing their duties, get cut off, the line gets broken because of a thermal battery runaway, that's the issue that really we should be thinking about as we're moving forward. It's a two-pronged issue that every single slide and every single video that you see, you need to attribute on both fronts, firefighter safety as well as public response.
All right, so the cells that we dealt with, that was spoken about a little bit earlier in the day, the 18650 cells, 18650 on the bottom. If you look at the AA and the AAA up top, not much bigger than that. They're not huge cells. 18650 is the size, 18 millimeter wide, 650, and then the 0 is a placeholder used in industry. This is a little bit earlier. Anode and cathode with a separator in between. When that separator becomes damaged, for whatever reason, it causes the battery to go in a runaway. When you take those single cells, you start putting them together, you start getting them into battery modules, and those modules go into battery packs. And the only reason I want to show you this is we put them in, we did 2 and 3 cell packages. When we look at the Tesla battery floor, the most popular Tesla battery floor has 7,104 individual cells attributed to it. So
somebody just said, Jesus, if something like that didn't run through your head as he's saying that, you're not paying enough attention. Jesus should, or some other expletive should have.
These videos, keep in mind, we had two cells set up, and then those other ones were 3 cell setups. This is 2 cells put into thermal runaway with a coupling, a heat coupling. We heat it up until it goes into runaway. Fully charged cells. So you just see the tremendous release of energy on it. This one, you can kind of see the thermal coupling right there turning red, heating it up, and then going. You can see we started putting our air monitoring up there to see if we can find out what the off-gassing was coming out of this. They found some idiot to stand there to take an air sample for the GCMS.
It's a lot like you.
It does. But if you watch the metering up top, you see 2 of the separate meters start going to alarm off of this. Another one in full charge, put in by heat. Again, it goes pretty quick. Once they start becoming compromised by heat, they go into runaway awfully fast.
I think we were seeing, what, about 4 minutes
Yeah.
by the time we flipped the switch to the time they went off?
Yeah, and that time was due to the thermal coupling actually heating up to the temperature it needed.
Right.
But again, every time we were doing it, the meters were picking it up. One of the interesting things that we're going to talk about further on, actually earlier in the runaway process, before it actually ignited, we were able to detect off-gassing from them. All right, so this one's interesting. This is a little bit of a longer video. These were discharged cells. 2 cells discharged to 25%. And you can see that small spark that was there. That wasn't enough to cause ignition of all the gases that were coming out of there, but those gases still measured to be flammable and toxic. And that was from a discharge cell. All right, so this was a thermal of a cell that was put in a runaway with a 50% charge rate. And you can see it kind of goes really fast.
These are not the thermal images, by the way, that you're going to be able to see on a fire camera. just in case anybody's going to take that and be like, oh, our thermal imaging camera is going to be able to pick stuff like this up. These are very, very high-end, high-speed thermal imaging cameras. Our fire camera is going to work off of kind of a different principle. So we want to make sure not to take this idea of, oh, I just saw this on a thermal imaging camera. I can take that and use it operationally.
This thermal imager started about $500,000, and they loaned us 2 of them to burn. So I don't know what the hell they were thinking. Yeah, we did. So this one was a different method of initiating the runaway. The mad scientist here came up with this air system that launched a dot into a cell and caused that cell to go and run away. And you can see it happened that quick. This is full speed. That dart went in there and the battery instantly went into runaway. At 25% speed, you can kind of see it go and strike. And how fast it went into runaway. And again, that's one cell. That is one cell slightly larger than a AA battery, is storing that much energy and sending out that much energy. Imagine what happens when we get 7,000 of them. All right, so some of the things that we talked about were different methods of packing. Some people talked about, hey, can we just pack this in Speedy Dry? And will Speedy Dry kind of help solve our problem? So we put a couple of cells in Speedy Dry, and still kind of off gas, still got the flammability. It's better than having the batteries go flying everywhere, but still didn't really suppress anything.
No. What the clay will do, remember, all these different options, they are there to try to fit your specific goals and needs. So as a chief of your area or administrator of your area, you really have to ask yourself, what's my goal? And it's really super important not to turn around and take and look at some big city and say, well, they're doing that, I'm going to do that. Because our goals and our hurdles that we had to go through are going to be different than your goals and your hurdles. So it's really important to understand the function behind the battery, what's going to happen to it, be able to predict its behavior and say, is its behavior going to hinder my goals? And what resources do I have to overcome X, Y, and Z? So just to be really clear, like the clay could be an option for you if all you're worried about is making sure that the thermal radiant heat from these batteries going off doesn't set something else on fire. If you're not concerned about the toxic gases, if you're not concerned about any of that stuff, this is a great method for you. But your goals and your hurdles have to align with this solution. Does that kind of make sense?
All right, so the next thing we did was we started using that product Cell Block. And Cell Block claims that they will start absorbing some of those toxic and flammable gases. Doesn't really work on pressure, but it does supposed to work to absorb some of them. That being said, this first video, if you listen closely, you're going to hear one of these meters go into alarm. As we heated it up and it was early in Runaway, those cells started off-gassing, and we could detect them on a meter before it went into full Runaway. Unfortunately, we could detect it through overpacking and Cell Block, which claimed we weren't supposed to. But give it in on it. This is what happened a few seconds later. So you can kind of see the residual gases that we still had potentially toxic gases that were there. We still had all our meters going to alarm. Because this was an open barrel, it wasn't really a fair test of the product. When it went to ignition, it kind of blew the product away. I'll get to that in a minute. What we found in all of the testing throughout, we had percentages of the LEL on just about every experiment we did. It's the highest levels we saw were up to 30% of the LEL in some of those rooms. And again, you got to remember, this was just off 2 batteries and 3 battery sets.
Right. What was the size of it was the Connex box. It was a Connex box. What was the size of the Connex box room that we were in?
Yeah, it wasn't huge.
I mean, 8 by 10?
8 by 10, maybe
8 by
12
10.
feet. Yeah.
So 2 cells were able to bring 30% of the LEL to an 8 by 10 room.
So some of the other things we found were the high CO levels. High CO levels might have been there. I tend to think more it was a cross sensitivity to hydrogen that we were seeing more than anything else, especially when I show you the next video. We did find hydrogen sulfide or something that had a cross sensitivity to it in there. Depending on where we were in the burn, we had increased and decreased levels of O2. And Blackline brought a specific meter with a hydrofluoric gas sensor in it. we were able to detect hydrofluoric gas readings with that. And there's going to be another presentation a little later by Tim Vamosi that's going to tell you why that's pretty bad. So the sampling that we took with the GCMS, these were all of the toxics that we found in that off-gassing. And this was consistent with other testing they'd done in other parts of the country. Pretty much the standard 18650 battery formulation, we're putting off all of this as off-gassing during the burns.
We got these same gases in cell block and vermiculite as well. So that also gives us an idea that there are no additional gases being given off by the clay or the cell block, just for anybody that has that kind of, scientific thought process.
So what we did here was we took the 3 cells and we put it in a 30-gallon drum, filled it with cell block, and just left the bung holes off so we could actually get the wiring in and out of there, and we put those in the Runaway. And we figured this would be a better sampling of what an overpack would more look like. So when we popped it, you still see the pressure, you still see a lot of off-gassing coming out of there. And when we took air samples with the FLIR GCMS out of there, we were still finding all the same gases in that headspace.
Travis, that's way overpacked.
I mean, so that overpacking is for full battery packs. We had 3 cells. So as we went in there, the other hazmat guy is coming up here to pull that thermal coupling. And I need you guys to watch right at that bung hole. He jumped like a little girl. You see him? That headspace was flammable. We pulled it out. We still had off gas. I don't think it contained everything that we were hoping it would contain. I did it in slow-mo so you can really watch him jump back. He's going to kill me when he sees this.
He is.
Yeah, that's going to be awesome. So, and you still saw the pressure, right? I mean, that is still a very, very flammable headspace. So that's why I'm guessing more than CO. I think there was a lot of hydrogen that was off-gassing from these batteries due to that kind of flammability we're seeing. So with only 3, I think it's going to stay in the container, right? Because that pressure is not quite as high as it would have been if it was a full battery pack. If it's I have real concerns sealing up a container like that. So much so that after this, our new policy in the New Bedford Fire Department is 5-gallon, 35-gallon. We tucked the top on. We're not clamping it down anymore.
Yeah, we haven't sealed the drums in about 3 years in the city. We have pretty much left them open. We ran some tests early on, and we were able to blow the top off of one 16-gallon drum with one of the 1865 zeros at full charge. So it's really important to remember that because this technology is so unstable, it's also extremely unpredictable. We can run the same test over and over and over again, and 90% of the time we'll get one outcome, and then 10% of the time the whole drum can blow apart. So as we move forward, this is so new to us in the fire service. It's really important to always keep that hyper vigilance as to what the potential could be, even though we may never see it fail to that degree. Every single battery has the potential to do that.
So one of the things that we were concerned about in New Bedford, we have a lot of high-rises, elderly high-rises. They use a lot of mobility devices. A lot of those devices use lithium-ion batteries. What if we had batteries damaged in elevators? How do we bring them down? Damage on upper floors, how do we bring them down? Do we use elevators? Do we use the stairs? How do we get these damaged batteries out of the building? So one of the thoughts was these bags. These bags were made by Cell Block for the airline industry. You get a damaged battery, stick it in there. It's supposed to contain the Runaway. They actually gave us this one to try.
Yeah.
Full authorization. They gave us this.
From them. They helped us
100%.
pack it. Yep.
They were 100% on board with this. So I'm of the opinion that I still don't want my guys in an elevator with a battery and overpack, whether it's in a bucket, whether it's in a bag, no matter what it is, my guys should not be in close proximity to those overpacks because I still consider them a danger. That being said, will I still use cell block to overpack stuff? Yeah, because I still think it does a better job than just vermiculite alone or sand alone. But but we still has to be used with caution.
We're allowing these in airports.
Yeah.
Again, unfortunately, it's better than the alternative of nothing. We still say there are no answers, right? None of us have really a clue what's going on. Honest to God, I still don't have a clue what's going on. We're just figuring this out bit by bit, building that plane as we fly it, as Bobby likes to say. So, we have to proceed with caution with everything we do. There is no 100% guarantee in any of this in any way, shape, or form.
All right, so just to wrap it up real quick so I don't go over and Kevin yell at me. The higher the charge, the more reaction we're going to get on cells. Where does that make a difference for us? If you're going to a fire at 3 a.m, what are going to be most of the charge levels of the batteries in that home? They're going to be up there at that point, right? So that's something we need to consider. Time of day, how charged the batteries are, will definitely make our job more difficult. We can detect the off-gassing. It might be a very, very quick reaction, but at some point, our meters will be able to detect what's coming out of those cells. Might not make a lot of sense. You might see an LEL, you might see an O2 issue, you might see a CO issue, depending on what's coming out of them, but the standard 4-gas meters we all use should be able to see something. We also learned that these cells were off-gassing very, very early in the runaway process. Well before they went into that spectacular runaway event, we could still get gases off of that and we could still detect them. The gases are highly toxic, highly flammable. If you have people that have been exposed to those gases, I would strongly recommend they get looked at, get some type of medical attention, because they are inhaling a lot of very, very different toxic gases, which I'm sure my good friend Tim is going to elaborate on that. And our overpacking. Our overpacking, while helping to mitigate the problem, is not a complete answer. We still have to consider those overpacked batteries as hazardous. Anything Ned?
Yeah, just to anybody that does have the elevators in their first due area, one of the things that we do is that we will, again, overpack in the cell block, put it in an elevator, but it rides alone in the elevator. We have full control of that elevator through the fireman key, and it rides to the lobby 100% by itself. We don't put anybody else in that, and we use the fireman key to bring it right to the lobby, so no other civilian can get into the elevator with it.
So again, apologize, but Mike's going to have to leave before the roundtable. If someone has any questions for him before he takes off, it's going to be.
My questions, paraphrase the question.
Sure. It seems that you did all your packing and dry stuff. In one of the videos we saw, the aircraft, they said they put it in salt water. Did you do any testing putting these batteries in water to get them out of where they are?
Okay, so the question is about what that is called is overpacking in a brine. So taking the batteries and putting them into a saltwater solution. So the idea behind a saltwater brine is that you're discharging the battery, and by discharging the battery, you're lowering the potential for a catastrophic thermal runaway event. It takes time, and before, I can't remember the name of the hurricane that hit Florida last year, but before Florida got hit by the hurricane, that was a prevailing thought that maybe we can do this way. And it is a possibility. I can get into it really quick as to why it is or not. But after Florida flooded, after the waters receded, a lot of cars went into thermal runaway. There were battery fires left and right, because we understand that putting them in a brine is an uncontrollable discharge. All these batteries need to be charged and discharged through a computer, through a microchip, has to be electrically processed, has to be the perfect amount of voltage going in and out, or it will go into thermal runaway. With that said, if we can find a brine solution that is perfect for the amount of discharge that the battery requires, then we might be good to go. It doesn't eliminate the hazard. It takes a very long time. There are departments out there that are doing it. I don't necessarily agree with putting it in a brine and then telling the homeowner or the responsible party, okay, it's yours from this point. That's a whole different conversation, but it is something that is being explored and is being explored heavily right now by the Navy, but no white papers have come out yet on how to do it, what the brine solution needs to be to keep that balance. No, in fact, I don't think we have a video. I have a video during the class that I show of batteries going into thermal runaway in a pop-up pool of a couple hundred gallons of water. So if Yeah, oh yeah, you can see them blowing underwater. You see the flashes underwater. You see the gases bubbling through the water through the pool. So if fully submerging the battery underwater isn't good enough to keep it cool after it's been injured and go into thermal runaway, no amount of water you put on is going to do that. What that will do is prevent propagation. So the damaged batteries, as they go into thermal runaway, it'll prevent the heat from transferring to the next cell. But the caveat to that is you have to have the water around the actual cell itself. Otherwise, it's totally useless.
So there's an interesting video that Baltimore Inner Harbor. Did you see the one of the?
The scooter.
There was one of the rental electric scooters went in a runaway. Person panicked, threw it in the harbor, and there's a video of it bubbling and reacting 20 feet deep in the harbor. Nothing stopped it.
In fact, I just saw a recent video of a Tesla in the water. I don't know if it was a Tesla per se. Don't sue me, Tesla. In Florida, right? And it is going into thermal runaway in the water. So we absolutely 100% know that it's very difficult for us to get the water into the cell. And once it's been damaged, right? We say this all the time. It's kind of like insulting a millennial, right? Once you insult the millennial, they're going to burst. You just don't know when. All right? So we want to make sure that we keep that in mind. We don't know when it's going to go fully into thermal runaway, but once it's insulted, once you insult that battery, it's just a ticking time bomb.
Dumpsters, they're filled with water that Europe's doing useless.
So that's a double-edged sword, right? So we don't necessarily know the full effects of that. It's totally against manufacturers' recommendation to submerge the batteries in water for the cars, right? If you look at the Tesla manual, Tesla very specific says, do not submerge this car as an emergency procedure. So the question then becomes is what kind of liability as a chief are you putting on yourself submerging a vehicle when the manufacturer specifically says don't submerge the vehicle? All well and good when nobody gets hurt, but what happens if somebody gets hurt? What happens if something happens? What happens if they're pulling the car out of the water later and it goes into thermal runaway and somebody gets hurt? What kind of liability is landing on your shoulders for going against manufacturers' recommendations? That could change next year. You know, NFPA could come out and be like, no, this is a viable solution. And then great, we have a consensus that we can work off of. But right now we're going totally blind.
New Bedford's taping the overpacked drums closed. New York doing the same thing, or you not covering?
So what we have, so the question is Bedford's taping the drums? What was New York City doing with their drums? We were putting the lids on and opening up both bung holes. And then we were putting almost like a sucking chest wound bandage over both the bung holes to allow it to breathe out, but not to allow contamination or water to go in case they were, left outside or it was raining. If it's a 5-gallon pail, we are literally just putting the lid on and putting a couple little tabs closed, but we are fully allowing it to ventilate. And if it were to blow, we want that top to blow out and not up. We want it to blow up, not out.
Taping them down, or just letting them sit on top? Or?
We'll use the band that comes with the open head drum, and we'll tighten that down, and then we open up both the bung holes. But yes, taping is just fine. You want as little pressure to build up as possible. That way nobody gets injured if it does have a pressure event.
All right.
That's it? All right.
Thank you for your time, everyone.
Thank you, Mike. One of the primary concerns of lithium-ion battery, the lithium-ion battery problem is the release of the toxic gases.